Right, good evening everybody, and thank you to so many of you for joining us this evening. It's great to see some new members and new faces joining us. And also thanks to Charlotte for giving up her time this evening to talk to us about a really interesting subject that's very relevant to the UK's geothermal development and the development of clean energy and clean heat here. So a quick intro for Charlotte. Charlotte is joining us from the Coal Authority this evening, and after finishing her PhD on mine water assessment at the University of Newcastle, she continued her research on mine water recovery and remediation. Following this, Charlotte went on to work as a renewable energy consultant with TNEI Services and later with FWS Consultants. In 2009, Charlotte joined Durham University, where she helped establish the Durham Energy Institute, was research manager for BRIT Geothermal, a lecturer in physical geography and an associate professor. In February this year, Charlotte joined the Coal Authority as their commercial manager. And like I say, today we are going to hear some great things and exciting work that those guys are all working on at the moment. So Charlotte, it is over to you.
Thank you very much, Helen. Thank you for the invitation, both to Helen and to Wing as well. So thanks very much for inviting me, and thank you to you all for giving up some of your Friday evening to listen. So who we are. So with the Coal Authority, when I started to work there, a few people that I knew said we didn't even know that we had a Coal Authority in the UK. So we're a non-departmental government body, and our sponsoring department is BEIS, which is the Department for Business, Energy and Industrial Strategy. And we were created in 1994 by the Coal Act, and we basically own and manage all of the coal mines across the UK. So around about 25% of our homes and businesses overlie the coal fields, which is not surprising because many of our major towns and cities were built on the strength of their coal reserves. And we have a kind of total of around about 23,000 abandoned mines. So we have absolutely masses of mines available to look at. So it's underneath a quarter of the country, and 9 out of 10 of our largest urban areas based on geographical size is underlain by coal workings as well. So there's a huge potential there that we see. So our role really is to protect both people and the environment. So we have round about 75 mine water treatment systems across the UK where we either pump water or water comes out of its own accord. And if necessary, we treat that before disposing of it at surface. So we do this to protect both rivers and also aquifers as well. So we're protecting underground water as well as surface water from the impacts of mining. We also deal with ground stability issues as well. So we have protected over 400 kilometres of rivers with the treatment systems that we have in place at the moment. And we have our head offices at Mansfield, which is near Nottingham in the Midlands of the UK. And there we also have a heritage centre where all the old abandonment plans are kept. So from 1872, when the Coal Mines Regulation Act came in, it was a statutory requirement to deposit the plans that you had when you were abandoning mines with the Secretary of State, so that people knew where they were, so that subsequent mining would not cause problems by maybe breaking through into old workings, causing flooding and danger to life, that kind of thing. So this was set up for lots of reasons to basically protect future underground working. But because this was only in place from 1872, there was obviously quite a lot of working took place before then across the UK. So in some places we have unrecorded workings. And if we have records that mines are worked and seams are worked in that area at around that time, we can probably infer that that seam was worked more widely. So it's a bit difficult. We have to watch out for old unrecorded workings, especially if we're looking at drilling through mined blocks for geothermal projects. And also in some areas, the mine ownership doesn't belong to us now and still belongs with private owners. So that might have been a big landowner or an estate owner at the time, which means that we don't necessarily have the plans. So we have to do a bit more searching to find them. And they may still rest with a local estate owner or a local landowner. So it can be a bit difficult. Some areas have more of that than others in the UK. Like parts of Northumberland are quite have quite a lot of mines in private ownership still, although they're not operating. So in the UK, we've had a period of over 3 centuries of mining for coal, which ended in 2015. So we have no deep mining left in the UK now. So there's some surface mining still going on, but no deep mines. And this was marked by the closure of Kellingley Colliery in North Yorkshire, which is 4 miles east of a big power station at Ferrybridge, which used to burn the coal that was produced at Kellingley. That stopped burning coal and closed in 2016. And the coal output that you can see on the graph here has been shaped by both political events, such as wars and strikes, technology changes, so switching maybe from steam to diesel and electric trains, and also cheaper imports of coal, and also the dash for gas, so alternative fuels also led to the decline of the coal industry. And in June, we celebrated 2 months without burning coal, which is the longest period since the start of the Industrial Revolution, so effectively since 1882. So we've just kind of passed that milestone in June, 2 months without burning coal to produce electricity. And in terms of what happens when you abandon a mine, so as you're working it, the mines are generally pumped out so that the water is removed and the miners can safely access the coal. As soon as the mine's abandoned, because pumping and moving water costs a lot of money, the pumps are generally turned off and the mines are walked away from. But over a period of decades, although everything may seem okay on the surface, what we find subsurface is water levels start to recover and rise back up to where they were or thereabouts. But the act of mining's created these new pathways through which mine water can emerge at surface. So if you can see my pointer here, for example, over on the left, you've got this this level here. Now, if this was on the side of a river valley, you could see that potentially you'd have an outflow of water there where there wouldn't have been previously. And then in this area over on the right, where the water levels are still rising, you could imagine that maybe if this was an aquifer up here, eventually these water levels could rise into the aquifer. So they can either threaten water-bearing formations above, or they can threaten surface waters. So this is why we have strategic points across the whole of the UK coalfield where we pump and monitor to keep an eye on what's going on. Some areas of the UK, such as in the northeast, Northumberland, are recovered, so the water levels are only a few metres below surface there. But some areas, for example, South Wales, are still rising, and there may be still a couple of 100 metres below surface in these areas. And this means that in future we're going to need more mine water treatment systems, and we need more monitoring to know what's going on in some of these areas. So we treat these gravity discharges that we might have, or pump water out from strategic points if we need to. And we also have photovoltaics at some of our pumping sites to offset the electricity costs of pumping mine water, because they run constantly and some of them are flow rates of 100 litres per second or more. So they can be quite high flow rates when we're going to have to do this long term. So the work that we're looking at in the innovation team at the Coal Authority, which is where I sit, is all about repurposing this legacy, and the focus of this talk obviously will be on mine energy. But the other things that we're doing is we're looking at water as a resource as well, because we handle a lot of water through the coal field. And the amount of water we treat per annum is equivalent to the daily water demand for around about 2 million people. So there's a good resource there. The problem with it is it's not all fresh. We have some fresh, some brackish, and the rest is hypersaline, so more saline than seawater. But even though there's not a high proportion of fresh, there's still other purposes that could be used for, maybe some industrial kind of processes. So we're looking at what role our water has in kind of water resource supply, based on the fact that the Environment Agency have predicted that there's going to be significant water shortages within the UK in the next 25 years. And also at our mine water treatment systems, we produce ochre. So our biggest challenge in the water is iron. It's relatively easy to get out of the water if you aerate it and adjust the pH if necessary. Most of the places we just need to aerate it and give it time to drop out of solution. We also have salinity, as I've already mentioned. Some places the water is more saline than sea. So where we discharge at coast, that's not a problem. But obviously if we've got those sites further inland, we have to think carefully about how we dispose of the water. But this orange ochre that's produced as we get the iron out of the solution, we have uses for that now. So all of the ochre we produce, we have a market for as pigments, soil improvers, and also in water treatment as well. It's really good at absorbing things from water, so it's particularly effective at phosphate stripping. So we're trying to kind of build a bit of a circular economy here with these products that we have to just try and make the best use of them. So I probably don't need to tell you all about geothermal because you'll all know far more about that than I will, but just to say that we do class the mine energy as distinct from ground source heat, which I'm sure you'll be aware is based on solar radiation warming the Earth's surface to maybe within a few tens of meters. So we do class mine energy as having the deeper source. And just to give you a bit of context, the deepest mine that we have is around about 1.4 kilometers deep, and the temperatures we see there around about 40 degrees. Most of the ones we're working with day to day are between 14 and 20 degrees, because not all of them are that deep, but we do have a few exceptional ones where the temperatures are a bit higher. So if we're thinking about delivering a mine energy project, we need to think about the type of working that went on in the mine, because that affects how water flows through it and how much water we can get out of it. So in the top left, there's pillar and stoop mining, which was generally carried out earlier than longwall mining, which is shown below. So in pillar and stoop, or room and pillar, you effectively leave pillars of coal in and you work kind of tunnels of coal out all around it, leaving the pillars there to support the roof. And it's quite, you can see why this was done earlier when there was less technology for roof support. You know, basically the pillars were left in to support the roof. And as time went on then and technology improved, methods where you had total extraction or longwall mining took place. So in this instance, you'd drive out tunnels as far as you were going to go into the mine, and you'd retreat, working across the coal seam left to right, backwards and forwards as you retreated from the mine. And basically, as you retreated, all the material above you would be coming down around you, so it would be unsupported. So as you were retreating from the mine, the whole material above will be subsiding down. So it creates different features underground after abandonment. So pillar and stoop, some of those workings remain open. We don't know exactly to what extent there will be collapses, blockages, floor heave. But in the longwall areas where we've got the broken material, which we refer to as GOF, then we know there's going to be kind of less flow of water through that, just because we've got this kind of loose fill rubble that's in these areas. The top right shows you just some of the connections that we find between the collieries. So we may have several collieries in one area, but we find generally they're connected together. And we know how they behave and respond because we've been looking at the way they're filling up with water. So they can be thought of as lots of different baths at different heights and with connections at different heights as well. And so from looking at water level rise or recovery in these areas, we can work out kind of how they're behaving and what's connected to what, which helps us think about where we might be drawing water from if we do a mine energy scheme. And the tunnel at the bottom is an example of one of the roadways that you might find in a mine. So these are great things to target. They're very well engineered because they were designed to take trains and move the coal out of the mine and bring people into the mine. So very well engineered, well built structures that often remain open after abandonment. And you can see from the size of that, you can imagine the flow of water you'd get through that is quite significant. So where possible, we look for these kind of targets. Where we don't have them, maybe if we're in an area of room and pillar, we'd look for an intersection between where the workings are, so that you maximise your chances of getting some flow if there is a collapse in one of the areas. So in order to work out where we might go for drilling targets, then we need to make sure that we have enough seams under the site, so that we have seams to take water from and seams to put the water back into. And you can see from this example that we have plans of variable age and variable quality. So the one on the left is obviously a lot more recent. And you can see on that one, the areas of room and pillar are this kind of grid pattern here. And then the areas of longwall are this pink dotted area. So we can know from looking at this that we probably wouldn't want to drill into these areas to target a good flow and be looking for some of the intersections here. This is a much older plan which shows the same thing. So it shows where there's been room and pillar, but then there's also been some longwall mining take place subsequent to that. So often areas of room and pillar were reworked because they left pillars of coal that still had good reserves in them. So they went back in and did longwall mining. And you can see here that basically the mine manager has just used watercolours to fill in or block out the areas that were taken away. So, I mean, these things are very accurate. They were very skilled at recording the underground, but there are bound, when you get to depth, there are bound to be some inaccuracies when you're looking to hit these relatively small targets at depth. So people often ask us about the kind of longevity of the temperatures that we see in mine energy systems, and we believe that, you know, carefully managed, we can maintain the supply temperature from the subsurface. And we've been looking at some data from across the UK. So we have an interactive map viewer, so you can look at particular areas and see what's underneath where you live if you're interested, and it shows you where the workings are roughly and where there's mine entries as well. And we're soon going to add a temperature layer to this as well, so you can look across the coal field and see what temperatures are at different depths. This is work we've been doing with the British Geological Survey, so they've been instrumental in this. But part of the data we got was because in the 1920s and 30s, they wanted to deepen the mines to get more coal out of them. But because with the depth they were getting increasing temperatures, it was getting quite hot for miners to actually work down there. So there was a big program to record the temperatures in the mines for kind of personal safety of the miners. And these data are quite useful for us now. So on this graph here, all the dots are recorded rock temperatures in South Wales. And the wiggly lines are where we've gone into mine shafts and done a water profile temperature down the shaft. And we find that there's good similarity between the dry rock temperatures and the water temperatures, which we see now, which is not surprising because it probably has equilibrated with the rock. But it shows us that, you know, that heat is driven by the geothermal gradient and is being replenished as well. So it gives us some confidence that correctly managed, we can have good supplies of temperature, you know, over fairly long periods. So the reason that we're looking at abandoned mines is, I mean, to put it in the context of geothermal in general, in the UK, we don't have any high temperature resources. All ours are low temperature, or in the case of mine energy, ultra low temperature. But what we do know about these systems is that they flow water. So it does remove some of the risk associated with drilling for lower temperatures where you don't know what the porosity and permeability is at, say, 1 kilometre or 2 kilometres below subsurface, and you risk drilling a hole that's dry. So here we're getting much lower temperatures where you need a heat pump to lift the temperature, but we can more or less guarantee there's a flow of water because we know so much more about the nature of the subsurface because of all the plans we have. So just to think about decarbonising heat, and there's some stats there on the right of various targets and things that we're trying to achieve. But if you think about the difference in demand between the highest daily gas demand in winter and the lowest in summer, it's about 4,000 gigawatt hours, which is 8 times the amplitude of the difference between the winter and summer electricity demand. The point being that can we realistically expect to shift all of that heat demand onto the electricity network without causing some problems? But by using heat pumps running at a COP of 4, then we can quarter that electricity demand. So although it's not removing it, it's reducing it significantly, which is another reason we're interested in looking at mine energy. So in order to deploy it, we estimate across a coal field that there's enough heat in place to heat the buildings that overlie it. And the benefit of it is, if you compare it to other water source heat pump systems, such as maybe river source, for example, or even if you compare it to air source, we don't have an interseasonal variation in the source temperatures. So the temperatures that we observe, we get them year round. So the coefficient of performance of the heat pump stays constant, and in some cases it can be reasonably high because we've got higher temperatures. And we normally look at using removing the temperature of 45 degrees of temperature from the ambient mine water temperature. So if you're looking at getting a megawatt from a mine, you're looking at a flow rate of something around about 50 litres per second. We're also looking at whether we can take more than 4 or 5 degrees out. Could we increase that a bit if we've got a big flow path, so that you could have maybe a lower flow rate and maybe your wells would cost a bit less. So we're doing some sensitivity analysis around all of that. And unlike aquifer systems, we come across a lot of instances where consultants say, oh, it's just like an aquifer system, and they pepper it with pairs of boreholes to abstract and return the water. We don't need to do that, because the tunnels that we're targeting for are so good at storing and transmitting water because of the sheer size of them, that we can get away with maybe 1 or 2 pairs of boreholes for a mine energy scheme. So we can do a lot less drilling to access this. And you can see in the diagram here that we look to abstract the water from a deeper seam. It then goes through a heat exchanger, which will drop the temperature by 4 or 5 degrees. The heat pump then boosts that up to whatever the user requires. And then that cooled water we re-inject to a shallower seam, and we make sure that we have a long flow path on the order of several kilometres between where we take the water from and where we put it back, so that it's got plenty of time to heat up. And although that can be many kilometres underground, we found that we can have the boreholes quite close together on surface. So they may only be a few metres apart, yet they're running massive different distances underground. So that's another advantage, because if you're working with a constrained site, it means that you've got a good chance of being able to fit both your boreholes within the site. So in terms of sustainability, then this is the example we're giving from our Seaham Garden Village project, which I'll talk about in a little while. But we've got steps in here which represent different build-out phases of this project. So as more homes are added, we have increasing steps on the graph. But really, it just shows you the performance of the mine energy network in terms of CO2 emissions against the counterfactual gas boilers. And as well as that, we see, as I've already said, stable temperatures. We can offer stable pricing because we know how the system is going to perform, and we can improve local air quality. And because people aren't burning gas in their houses, risks of things like carbon monoxide are removed as well. And it's really compatible with district heating, so you don't need to think about transporting fuels in. You can just drill boreholes to fit into your network. It's got lower temperatures, so it's got higher efficiencies than compared to something like gas-fired CHP, because there's lower system losses because the circulation temperatures can be that much lower. And it offers an alternative that can be used at scale in former mining areas, especially if gas is being removed, which is what the UK government's planning from 2025. So in terms of heat network opportunities, there's several ways you can deploy it. You can use a centralised network. So the Seaham project that I'll talk about shortly is a case study. There we're going to have a centralised heat pump in an energy centre that will raise the temperatures to 60 degrees. And that means in the homes, each home will have a heat interface unit rather than a boiler. So that means for the builder, they can still put in normal radiators, and the actual house doesn't look that different for the buyer, but it offers a way to connect to a network in a way that's fairly convenient and familiar to people that are used to kind of conventional systems. And what's more interesting to me are the decentralized ambient loop systems, which are much more efficient because you're circulating the water at the temperature it's coming out of the mine, and then you're just upgrading the temperature at the point of use as well. And these systems can work really well where you've got cooling in the network as well. They're a bit more flexible, so you can add people onto your network by just adding on heat pumps in various buildings, as long as you size your pipework so that you're planning on it growing in future. And the other advantage is that you could put your boreholes anywhere on the network rather than having to have them at the energy centre. So in some cases, you get a bit more flexibility. The way these things are financed is different, because obviously if you're in a centralised system, you're going to be buying heat off whoever's running the heat network. But in a decentralised system, you're probably just going to be paying for electricity from your electricity supplier. So in some ways, these are put forward as something that, again, are a bit more familiar. So people would just have a heat pump in the house and they'd still be able to switch electricity supplies like they do now. So there's pros and cons to each. So the potential, we're looking at the kind of bigger system as a whole across coal fields and across connected collieries. And we're looking at integrating various energy sources and various demands. So for example, we could use renewables, and we could use waste heat from data centers to go back in. We could look at waste heat from sewage. We could have solar farms feeding in. We could have wind farms feeding in heat when they weren't producing electricity and helping to balance the grid. And then you can see we're putting all this into the system at one end, and we can use the subsurface almost as a heat network itself and use it to transmit the heat for us. And then we'd have maybe a housing development that would take the heat. And then you could also move that on to something like a horticulture project where you're growing as well. So we're looking at the potential of mine energy for horticulture to improve UK food resilience as well. Some of the other things we're looking at is we have 177,000 or so known mine entries in the UK. About 134,000 of those are mine shafts. So the other ones will be adits, horizontal or sub-horizontal tunnels. Of the shafts, many of those are filled, but those that aren't, we do have several deep ones that have reasonable stores of water in them. So we're looking at using those as thermal flasks. We've also been asked whether we can store hydrogen in them as well, so we're looking at the potential of that. And also we've been approached by people that are interested in dropping weights down shafts to use that to generate electricity. So we're quite interested in the potential of the shafts that we have, and the way they're mapped on our systems, it doesn't make it very easy for us to search for them to find out the best ones, but we're working on that as well at the moment because we can see their value too. The opportunities we have, so we have places where we pump already. So we've got water available at surface there that we can just connect to an end user as long as they're nearby. So the location can be a bit constrained, but because we've got to do that anyway, it doesn't really matter if it is used, it's a benefit. If not, we've got to do it anyway, so it's going to be there regardless. And from what we pump out across the UK coalfield at the moment, we have about 100 megawatts that currently goes to atmosphere. So we are working on a few projects now that will start to use that resource. The other example is where you've got, so you're putting a single installation. In this example is a leisure centre in County Durham. So you can vary the location, you can obviously pick a site that is over the coalfield to have this, but the upfront capital for a single installation is quite high, so that can affect the economic viability. And then you've got the kind of larger schemes where you've got heat networks, so you've got loads of clients and people to sell the heat to. So that obviously comes with its own problems given the lack of heat markets and regulations that we have at the moment. But they do offer economies of scale and the potential to decarbonise heat at scale, and lots of new business opportunities as well for new companies to sell heat, service heat networks, install heat networks. So there's loads of interest in heat networks at the moment. And this is just some of the project stages we go through when we're doing a mine energy project. So we've done quite a lot of feasibility work so far. And now with about 3 or 4 of our sites, we're now moving into stage 2 with those where we're doing pilot drilling and borehole testing. So that's getting really exciting now to see what we're going to find when we get down there. Stage 3 will be, once we've drilled these test boreholes, we're then drilling the abstraction and recharge boreholes and testing them, connecting up the top side infrastructure and commissioning the scheme. And the final stage is having the scheme up and running, selling heat, monitoring its performance and gathering the data from that. And the ways to optimize a project are to have as many uses for that energy as possible. So having a range of customers and demands to maximize the demand on the system. Using cascades. I know Helen's done a lot of work on geothermal cascades. These are really, really low temperature ones. So perhaps you could have the mine water coming out at 20 degrees. It would go through a housing estate. It would leave the housing estate at 15 degrees. It would then go through a glass house and leave there at 10 degrees. So you've got kind of two bites at it really to maximise the use of it. Having anchor loads is key, so that you've always got some demand there. We can target particular industries, so we're thinking about who wants the kind of heat and the profile and the temperatures and the characteristics of the heat we could supply. We're thinking about which industries would want that and talking to them. We're looking at storing energy in the mines as well as supplying. And then there's also some social drivers we're looking at. So in coalfield areas that are off gas, where there might be old housing stock that's solid wall, hard to treat to improve its thermal performance, we're looking at what can mine energy do to help improve comfort levels and reduce fuel poverty as well. So we do have some challenges. So what's going to happen to the renewable heat incentive, which funds people who have heat pumps running on mine energy or other geothermal projects as well. So that funds them, and pays them per kilowatt hour of heat they produced. Issues between interaction of state aids and subsidies. As I've already mentioned, there's lack of regulation for heat networks. How do we bring back jobs and skills to areas that are still suffering high levels of deprivation from the closure of the mines? We've got to get people educated and thinking about different ways they could use and trade heat. So thinking that you might buy heat instead of buy gas. You might not have your heat from a gas boiler, you might have a heat pump or a heat exchange unit, you might be buying hot water effectively. So it's all of that, getting the end user signed up to it and to understand what they're doing. And ensuring that the projects are developed well. So we've seen some projects that we've not been involved with where there have been problems. So we're working hard to make sure the ones that we do will work well. And on that, we will be building kind of a best practice guide on how to develop mine energy projects going forwards. So we've got lots of opportunities across the UK. This list, I think, has gone up since I put this together. So we've got around about 74 live projects. And we've probably got 3 or 4 projects now moving to the drilling stage. So it's a really exciting time for us now to push this forwards. This is the Seaham Garden Village project I mentioned earlier. So we're pumping water continuously at the former Dordon colliery, which is up in the top right corner. Well, the colliery is not there, but the treatment system is. And that closed in 1991, and the water there is at 20 degrees, and we pump about 150 litres per second. And we treat that within the little shed you can see there before discharging it to the sea. So the idea is that we'd intercept the heat going through the treatment plant with a heat exchanger. We'd raise the temperature to 60 degrees, and then the homes could have heat exchange and heat interface units and normal radiators. So the idea is that it would be as normal as possible and as easier for the developer to do as possible. This project's being led by Durham County Council, supported by Toland, which are the developer of the site, and there will be some housing developers will come in to build the houses. 1,500 homes are planned for the first phase, and half of those will be affordable homes. Another project we're working on, so this is one we're about to drill kind of late summer, so the Gateshead project. They already have a heat network there, very proactive local authority that are really interested in decarbonising heat. So this is an extension to their existing heat network to the tune of about 6 megawatts. So it's going to be a big extension to it. Oh, I think I've just jumped 2 slides there. So hopefully that's given you a bit of an overview of the kind of things we're doing, and we now view something which was always previously seen as a liability as an asset of strategic importance because of the things it can offer us in terms of energy supply, potentially food supply, food resilience, water supply, and then obviously things around resilience of communities, commercial opportunities, and it fits really well with the kind of government intentions and incentives for clean growth strategy, our energy strategy, and also our industrial strategy. It all fits really well into that as well. So it offers a really good solution to decarbonise heat at scale, and particularly if we can combine it with other low carbon sources of heat and electricity as well. So thank you very much for listening, and I'm happy to take any questions.
Great, Charlotte. That was a really interesting talk. Thanks ever so much. Oh, it makes me really excited listening to all of that, actually. I'm so obsessed with cascade systems and sustainability and all sorts of stuff like that. It's really exciting. And now that we're getting to actually see some of the potential of what we can do in the UK, I think this is, it's just great for the industry, I think. So yeah, we'll open the floor to any questions. If people want to turn off turn on their videos and turn on their microphones if they wish to. And yeah, we can open the floor to some questions. So if anybody has a question they'd like to start with. Peter?
I've got a question. Thank you very much, Charlotte. That was very interesting.
You're welcome.
Are there, I presume there aren't many, but are there any sort of full-scale commercial operating systems in the UK? You've obviously got a lot of prospects and a lot of potential projects and lots of projects under development. Are there any that you would say are up and running and performing? And if that is, which I suspect it is, quite a small number, what's getting in the way? I mean, so obviously such a good idea. What is stopping everybody rushing like crazy to do this? Is it the problems with RHI and the problems of a lack of a sensible heat market, or something else?
Yeah, I think probably it is partly to do with that. I mean, what we have is the UK's biggest geothermal system at the moment is actually a mine energy one at Lanchester Wines. So it's just under 4 megawatts, and it heats 2 wine warehouses to keep the wine at the perfect temperature before it goes out. So that was developed by a company that were very committed to sustainability. They had already done wind turbines and solar panels on their other sites, and they really wanted to do something sustainable there. And they knew that the warehouses they'd just bought, they were in quite bad condition. They'd have to do quite a bit of work to them. So they decided to look at a mine energy scheme, because I think they didn't have a connection to gas either. So that was the driver for them. So I guess one of the reasons it hasn't happened is because we've had cheap gas and plentiful gas for a long time. Now that's changing. I think people's attitudes are changing, and also with all the climate emergency. I mean, we're more or less exclusively at the moment working with local authorities. They seem to be coming forwards first to develop these schemes. But that company did it basically because they wanted to improve their sustainability credentials.
Okay, thank you.
Does anyone else have a question?
I've got one.
Robin, yes, if you'd like to go.
Charlotte, that was a great presentation.
Thank you.
Obviously, he says, at those sites where you're treating the water and then discharging it, you're in a fantastic position because you've got clean, pretty much cleanish water to play with the heat network and the heat pumps. But I guess a lot of your potential is at places where you're not necessarily treating at the moment. Are you looking at those, and what are the challenges in terms of the chemistry?
Yeah, we're looking at, I mean, the one, for example, in Gateshead, it's not from a pumped mine water, that'll be from purpose drilled boreholes. So the intention is to, the mine water isn't circulated around the heat network. We just basically take the heat out at surface with the heat exchanger and put it back underground. So we're very careful to exclude air from the system. Our biggest problem is iron, and obviously salinity at because some of the seams that we pump from are quite deep. So we just make sure that the wells that we specify are geared up to cope with that kind of harsh environment. And then we're very careful to make sure that air is excluded from the system so that ochre doesn't have chance to precipitate. And when we re-inject, we always re-inject to flooded seams as well to avoid that, because quite a few people have said, well, why don't you just re-inject to a dry seam? It'd be so much easier to get the water away, and it probably would, but I think we'd probably clog it quite quickly. So that's how we tend to do it.
Anybody else with a question there?
I have a question.
Yeah, sure. Alexis, yes?
Hi, so I just was wondering if there's any thought being given to like whether or not the temperature changes in the mines, in the rocks, as you put the cold water back in, and what the kind of sort of maximum rate of extraction is without cooling the area down.
Yeah, we are starting to look at that. So we're interested in undertaking some thermal modelling. So we've been developing some like 3D models of the mines, so that we can eventually start looking at putting kind of flows and temperatures onto that. I think it might be quite variable depending on the flow paths that you've got and the kind of the time you've got for the water to heat back up, but it will be increasingly important when we get to this, to the having more than one system in one particular mining block. So it's something we're quite aware of. And with the Gateshead one, which we're on with now, because the seams are relatively shallow there, we're going to see if we're already putting in one monitoring well there for our own purposes, which is separate to what the council will be doing. But we're looking at the possibility of putting more monitoring wells in, so that we can see what will happen over time. That's also quite near to the system at Lanchester Wine, so we're looking at, you know, getting the data from that, the data from Gateshead, and maybe other ones that might be developed subsequently to get information on that.
Cool, that's
a good question.
Yeah, cool. Thanks.
Is anybody else there?
Yes, I have a question.
Yeah, sure.
So we're in the US, and I'm very interested in this. I covered mining for a very long time, for 30 years as a reporter, so this is very fascinating to me. Our mines, except in the South, in Alabama, are not as deep as yours. They tend to be 200 feet or less. Have you done anything with dual systems where some of your drilling is not so deep, so you actually have cooling in the summer along with heating in the winter, or is that not possible, or just too complicated, or?
Well, we find that, you know, in some of them, the temperature, you know, if we've got temperatures of like 14 or something, there's not, if we've got 14 in an area, the difference between where we're taking it from and putting it back won't be that much. Obviously it will when we started the heat extraction, but if you were to just look at the temperature difference between the two different seams, so something that's at that temperature, you could just use it directly, I guess, which is, I think, there's a project at Heerlen in the Netherlands, and they do a lot of cooling there. Their mine water's a bit warmer as well, but they also do cooling there too. That's been running for about a decade now.
Okay.
So it would certainly be possible to look at that, depending on what temperature you've got in the mines. But if they're shallower, they probably won't be that warm. So you could just use it directly.
Yeah, they're not, yeah.
Anybody else?
Can I get another one?
Of course you can.
A big barrier to some of these systems in the UK a while back now were non-technical. They were all about ownership issues. East Lothian in particular was a good candidate and fell apart on ownership. Is that still all addressed on an individual basis, or are there some generic things coming into play, and or does the coal authority have a bit more clout to sort some of those issues out?
I mean, we don't have any powers as such. We do license the access to the workings. It's the Environment Agency that have the powers from the environmental perspective. I mean, most of the mines we own, but we do occasionally come up with a site and we think, well, that's great, there's a couple of shafts there already, and we don't own them. They might belong to the local authority or something. It's unusual because we do have most of them. But it depends. Are you referring to land ownership around maybe somewhere where we're pumping that might be owned by a developer or something? Is that kind of what you're referring to?
I think that's what there was, some of the complications of who owned the mine, who owned the surface, and it proved very difficult to break through some of that. You know, the technical issues could have been were surmountable, but it all dissolved on issues of ownership. I'm just wondering whether that's been made any easier today, perhaps.
I think, I mean, most of the ones we've done are local authorities, so they're owning their land that we're working on. The one at Seaham is obviously owned by a developer, and that developer won't be the house builder. They're just the kind of site developer, put the service in, that kind of stuff. So there'll be volume house builders and a housing association come in to build. and I think they will be purchasing the land off them. So it seems to be working okay there. I guess it depends if you've got little bits of land in the middle that people don't want to buy into the scheme, so then you can't get enough customers to make it worthwhile. You could conceivably have issues there. We've got one in Scotland that I think that was a bit like that, a different one, but the site seems to have been hived up into smaller bits now, and one of the developers there has got a couple of those sites and is very keen to look at it again. So I think it might be changing a little bit.
Anybody else thought of anything? No? Great. Oh, Robin, are you back on? Did you think of something else?
I'm guessing that you're benefiting from the huge enthusiasm for heat networks from BEIS at the moment. I mean, I think that's the other thing that's changed. That you're seeing central push from government on heat networks, and the more geothermal and or mine water based systems we can get into those networks, the better for us.
Yeah, I mean, it's great. I mean, we don't get involved in the heat network side at all, because like at the Seaham one, where our pipe connects up to the heat exchanger is where we stop effectively, but we are very involved in that project because we want to see it happen, and we have put a lot of time and effort into trying to get it to work and addressing various issues that have come up along the way. So yeah, I think the heat networks are a great opportunity. I mean, not for us, but just, I mean, for geothermal itself and for mine energy itself, I think it is a really good opportunity. Yeah.
Great. That's I think that's everybody. Yeah. Thanks ever so much, Charlotte. It was such an interesting talk. Really enjoyed that. I'm sure Charlotte will be happy to answer questions if you randomly think of something. Her email address is there, albeit no doubt you are very busy, so be kind also. And this will be, this has been recorded, so we'll be posting this up on our YouTube channel, hopefully within the next week or so. At the end of August, we've got Nadia Narayan from Durham University, who's going to be talking about another really interesting aspect of geothermal, and that's geothermal from karst systems. So we're really looking forward to that as well. And anybody who's joined us this evening who is new to Wing, you'll see that Claire has posted the link in the chat, so you can go onto the website, find out more about Wing, join up and keep informed with everything that's going on, whether it's in your home country or globally. And you can find lots of information on our social media pages as well.